All right, now in this section, we'll be working on integration by substitution method. So first of all, you look at the results on the right-hand side, that if you have any function like x to the n type, which is algebraic power function, the integral is x to the n plus 1 over n plus 1. That you know very much, right? That you raise the exponent by 1 and write that exponent also in the denominator. That's the power rule of integration. Next, the integration of 1 over x. This is one special function because we know the derivative of natural log of x is 1 over x. So the integral of 1 over x is natural log of x. And that's why sometimes we write some condition in here that n should not be -1. If it is -1, then you go to the second one. It's natural log of x. Otherwise, you can use the power rule. Then the integral of e to the x will be e to the x. Sine x will give you negative cosine x. Cosine x gives you sine x. And I just write one property that if you see any exponent on the argument for logarithm, so that you can move in front, it's not the derivative or integral. It is by the rule of logarithmic properties. All right, so let's work on the problems we have right now. You have integral x to the 5, and then within parentheses you have 1 plus x to the 6 to the 9. Now if you look at the second argument, 1 plus x to the 6 to the 9, this is highly nonlinear, and I cannot expand the terms because it is time consuming. So that's why we are trying to convert this problem to some format like all the formulas you see on the blank screen on the right hand side. Okay, so we'll try that one. So let me show you how with suitable transformation we can convert this problem to a nice form. So just keep in mind that integral of x to the n is x to the n plus 1 over n plus 1. So now this is very complicated problem we are having. In this case, we want to make a substitution. Let me say u equals 1 plus x to the 6. And then take the derivative both sides with respect to x. You get du dx. The right hand side will give you 6x to the 5, right? You understand by derivative rule. Now what we see, du equals 6x to the 5 dx. Now in my problem, when I call this one u, so I get u to the 9, and then x to the 5 dx, now I can find from here, which is 1 over 6, du is x to the 5 dx. So we substitute back here. So you are writing like dx, and you can keep 1 over 6 in here, right? So that's the whole substitution. Now 1 over 6 outside, u to the 9, sorry, this one should be du because we see here du. Now is this problem exactly look like the formula we have here in the top? That we have exponent that will increase by 1, and it is with respect to u. So we are writing 1/6 u to the 9 plus 1 over 9 plus 1. So that means you got 1 over 60, then u to the 10, right? And what is your u? Substitute back, which is 1 plus x to the 6 to the 10 plus constant. And that's your integral result. And you see exactly we have it here. 1 plus x to the 6 to the 10 over 60 plus integral constant, right? Now you can see second example. In the second example, we are doing the same thing. We say 1 plus x to the 6 is my u, and the same way you find x to the 5 dx is 1 over 6 du, and substitute back. So you see 1 plus x to the 6 is written as u, so e to the 9, and then dx is replaced by du over 6. And then this one, I want to see precisely what is the exponent, which is -9, and then again apply this formula. So that gives you u to the -9 plus 1 over -9 plus 1. And after simplification, you get your answer this. Substitute back what is u, and you are done. Same way this one. Now I do not have any exponent in here. With the same substitutions, you get 1 over 6, 1 over u du, right? So that one is now going with the integration. We have seen 1 over x dx gives you natural log. So I get natural log of u must be within absolute value sign. And then substitute back. That's it. Example number 4, we have natural log of x to the 3. And you remember I gave you a property that this 3 can move in front, then look like natural log of x over 5x. Now again, this one doesn't fit with all the formulas I have mentioned before. Now if you say natural log of x is u, so 1 over x dx will give you du now. Okay? See from here. So that exactly we tried here to substitute. So natural log of x is written as u and 1 over x dx is du. And the coefficient we have 3 over 5 just moved outside. And the integral of u is u squared over 2, and then substitute back what is u, which is natural log of x. Now in this case, remember square is on u and use the whole natural log. So make sure that you use this whole parenthesis in here after you write square. All right. So other examples are very similar. Look here. This one, the same way we are going with. Natural log of x to the 3, I just move 3 in front. So 3 times 8 is 24. And then 1 over x, natural log. You just say natural log of x is u. So you get 1 over u. And 1 over x dx is replaced by du. And then you can complete this part. Similarly, example 6, we are taking the inner function because we know the integral of cosine x. Any other terms you have around should be replaced or substituted with suitable choice. All right. So we are saying u equals 5x squared minus 3. Take the derivative and you get du dx is 10x. And you can see here x dx remaining. That is replaced by du over 10. And then it is now converted to simple integral format cosine u. And the integral of cosine u is sine u. And after that, substitute back your u, which is 5x squared minus 3, right? Number 7 is similar problem, but it goes with the fundamental theorem of calculus. So first, let me look at the exponents after a simplification. X is there, you leave it. 8 plus x squared under the cube root sign. So that means it has exponent 1/3. And then 8 plus x squared will be considered as substitution for u. Take the derivative. You get du over 2 is x dx, right? And then substitute back. 8 plus x squared is replaced as u, so it will be 1/3. X dx came out as 1/2 du. Now this is standard power rule formula, right? So I need to add 1 with it. Okay, and we got this one. So let me see if you guys are having little difficulty with addition things here. You can take help in your calculator. I can do in my calculator and put it back as a fraction. 1 divided by 3. 1 plus 1/3. Hit enter, so you get this answer. Then you go to math. And from math, you choose 1 for the fraction, hit enter. So that gives you 4/3. So then you put the exponent 4/3. And here is a 4/3. So when you have 4/3 in the denominator, and it's reflected back in the top, it will be 3/4, right? You know, reciprocal format. So we got our integral after substituting back u, which is 8 plus x squared, right? And then plug the limit. So you know x is square root of 19, so x squared will be simply 19. Minus, then you replace x by 0. So you get 8 to the 4/3, yeah? Sorry, 8 plus 19. So 8 plus 19 is 27. And then you have 27 4/3. And again, if you want, you can do it by hand or check in the calculator that you have 27 exponent 4/3. That gives you 81. So we plug it here. In the same way, 8 to the 4/3 you can simplify. You give it 16. And then after that, simplify. All right. So that's all we have for this section. Thank you.